In this video, you will learn about how the man-in-the-middle examples work. You'll see how Keychain provides additional data security over legacy protocols, and learn how Keychain helps decouple security from architecture. A man-in-the-middle attack is a cyber attack scenario where two parties believe that they are communicating directly with each other. But in fact, there is another entity in between, which we call the man-in-the-middle, or the front-end server, which is actually intercepting messages sent from the client before those messages are sent to the back-end. And because systems can be quite complex, there is no real way of knowing how many hops in between the client and the back-end server have to be made before the back-end server actually receives the message. We will show you videos of sample applications available to you to provide you with an understanding of the security features of the Keychain Core SDK. There are three different cases for these man-in-the-middle examples. They are pass-through mode, where the front-end server simply receives and passes through the data directly to the back-end server without touching it. Modified mode, where the front-end server will modify the data it receives from the client and then send that modified data to the back-end server. And then there's insert mode, where the front-end server is going to, when it receives a message from the client, it will first send its own message to the back-end server before sending the message that it received from the client. And between those three different modes, we have two scenarios. One where we run without Keychain to show the effects of not having data security turned on. And the next scenario where we run with Keychain in all three modes to demonstrate how Keychain will protect your data. Keychain Core SDK provides you with the building blocks to integrate data security into your application from the application level before the transport level. And here we show the different layers involved. In this diagram, the Python, the Django app illustrates the position of our front-end server and back-end server, which are written in Python and Django, and the client application is written in Java. These can be any application written in a variety of languages that we support, which includes C, C++, Java, Android, iOS, and Objective-C, and Swift, of course, for iOS.
We will now demonstrate the Keychain man-in-the-middle demo running in pass-through mode without Keychain. And essentially what will happen is that the client here on the left will send a message on this HTTP connection. The front-end server will receive that message running here in the middle, and it will then pass that message on to the back-end server. So to start the client without Keychain, we run this command. To start the front-end server without Keychain, we run this command without the extra parameter of Y, because that means that we want to run with Keychain if we have a Y here. Otherwise, that means run without Keychain. And when running without Keychain, we want to make sure that we're running on port 8000. And let's go ahead and start that, and then we'll start the backend server in a similar way. In this case, it's running on port 8001. So let's go ahead and make sure that the front-end server is indeed configured for pass-through mode. So after logging on to the Django administration screen, you will be presented with this view or something similar. Click on relay modes. If you need to change it to pass-through mode, you click on this add relay mode button, which brings you to this screen, and then you'd select pass-through mode from the drop down here and click on save. And we are in pass-through mode. Now let's send the message from the client and see what happens. Send the message by pressing enter. So here's the message that the client created, And here is the message that it sent. It's the same message, obviously. It first creates the message and then it sends the message. And in the pass-through mode, the front-end server receives that message. And while we're not actually logging what we are sending to the backend server, it is essentially the same message. And as you can see, the backend server has received the message that was passed through by the front-end server. And because it's not running with keychain enabled, there's no signing, there's no encrypting. And so it's essentially the same message that was sent from the client, and it doesn't realize that there was a man in the middle that actually touched the message in between. So that is the man in the middle demo running in pass-through mode without keychain enabled. Now we're going to demonstrate the man in the middle demo using keychain enabled. So to start with the client with keychain enabled, we use this command here. And you can see some additional messages that are going to be printed out here, which shows that we are running with keychain enabled. Start the two servers with keychain enabled. We started with port number 9000 for the front-end server, and the additional parameter of Y indicating that we're starting with keychain. And there's a keychain license check, which shows that we're running with keychain enabled. Same for this server. Again, this one runs on 9001. Again, with the extra parameter Y to indicate we're running with keychain. And there's keychain license check again, showing that we are indeed running with keychain. The default mode for the man in the middle demo is modify mode, in which case the man in the middle will modify the data. We want to demonstrate first the pass-through mode. In order to run in pass-through mode, you need to run the Django admin server connected on port 9000, which is the same as the port that we connected front-end server here. To change the relay mode, click on this button here, select pass-through, and save it. And now it's running in pass-through mode. So let's see what happens when we send the encrypted message. Hit enter. There was the encrypted message again that was sent from the client. He received it. He was able to decrypt the message. That's why we're able to see the JSON here. This is the actual message after it was encrypted. And he just decrypted it because he is paired with the client. And then he just simply sends the unmodified message to the backend server. So that's the original message that was sent from the client to the man in the middle, who then just simply, like I said already, forwarded it to the backend server. And he was able to verify the message and accept from a known signer, which was the original signer. So that is the pass-through mode. Now we're going to demonstrate the man in the middle demo running without keychain in modify mode. We'll start up the client without keychain. We'll start up the front-end server without keychain. We'll start up the back-end server without keychain, and then we'll configure it so that the front-end server will be running in what we call modify mode, which means that it's going to modify the original message that the client will send to it, and then send that modified message to the backend. To start the client without keychain, we basically run this script, run demo.sh. Now we'll start the front-end server without keychain, and to do that, it has to be listening on port 8000. And we get rid of this last parameter here because this last parameter means, yes, run with keychain, but we don't want to run it with keychain, so we'll get rid of that. And start it up. So there it is, running on port 8000 without keychain. Same for the backend server. So we'll start it up without that extra parameter. And also it's configured to run on 8001. And it's now running without keychain. Now we want to put the front end server into modified mode. To do that, you need to be running the Django administration screen, and it also needs to be connecting to port 8000, which is the port that the front server is listening on. So there you see the Django administration screen has connected to the front end server. Now to put it into modified mode, you click on relay mode. It's currently in insert mode. To change it to modify mode, you just click on the add relay mode button. And make sure that this drop-down lists the modify selected. And then you click on save. So now it's running in modified mode. So now let's see what happens when the client sends a message to the front server. The client creates the message here. And this is where it sends that message. Unencrypted because it's not using keychain. And it got a response of OK. This is where it received the message from the client. And it is running in modified mode. So what happened is that it has modified the original message by adding this to the JSON, modified by hacker. Okay, that's what we call modified mode because it's modifying the original message. And then it sends that message to the backend server. And here you see it has received the message that was modified by the front server, modified by hacker. And because it's not running with keychain, it does not know that this message did not come from the client. So it thinks that it was a successful message and it accepted it. So that's what happens when we are running without keychain. And this is true for any web-based application or for any application. It doesn't matter if you're using HTTP or TCP/IP or whatever the communication mechanism is. If you're running unprotected without keychain, this is a potential problem. The man-in-the-middle attack, where it intercepts the original message, modifies that original message, and sends the modified message to the backend server. And you could imagine what this can possibly do in a production environment. So that is our demonstration of the man-in-the-middle demo app running it without keychain in modified mode. Okay, so now the next we want to demonstrate the modify. So for modify mode, I'm not going to restart the three components here because this is modify with keychain. We already see that it's printing out the keychain messages. I'm not restarting this. I already showed that when I first started it, that it was running with keychain in it. The only thing I'm going to do now is to change the mode from pass-through to modify. So in order to do that, you click on the add relay mode. The default is already selected, which is modify. And then I click on save, and now we are in modify mode. All right, so in modify mode, we send the message from the client by hitting enter. Okay, and here you'll see that it has successfully received and decrypted the message, and it is modifying the message. It is sending the modified message to the backend server, and the modification it made is that it added this text here to the decrypted message, and then it has signed and encrypted this modified message and sent the modified message to the backend server. So here the backend server receives the encrypted and signed message, which was modified by the man in the middle. It has decrypted the message successfully here. And as you can see, it is the modified message that the man in the middle sent. Now here, you see that it was able to verify the message However, it has detected that it was modified. It was not, the message was received from a signer that it did not expect to receive it from. It was expected to receive the message from the client. This message had the signature of the man in the middle instead of the signature of the client. So it detected that the message has been tampered. And because of that, it would not accept the message. Keychain protects your data end to end. And no matter what the man in the middle tries to do to your message, because both the client and the server are both using Keychain, they're able to detect that the message has been tampered with, and you can then take whatever appropriate actions are necessary. Okay, so now we're going to demonstrate the Keychain Man in the Middle demo running in what we call insert mode. And the way insert mode works is that the client here on our left side is going to send a message to the front end server here in the middle. And the front end server is going to insert its own message, sending its own message to the back end server before it sends the original message that was sent from the client to the backend server. Okay, so in other words, client sends message to the front-end server. Front-end server first sends its own message, followed by the message that was originally sent by the client to the backend server. And this is running without Keychain. So to start the client without Keychain, we would use this script. To start the front-end server without Keychain, we would use this script. And it's important that you understand we need to use port 8000 because that's what it's configured for when running without Keychain. You'll see why in a minute. And the backend server, we start it running on port 8001. So now they're all running without Keychain. In order to put this into insert mode, you need to go to the Django administration screen. And the important thing is, like I mentioned before, the backend server is listening on port 8000. So you need to make sure that you connect on port 8000. In order to put it into insert mode, you go to where it says front end, relay modes, click on that. And to put it into insert mode, you click on add relay mode. And you change it via the drop-down list here, selecting insert. And we just click on save. And now it is running on an insert mode. You might have seen some action here when we did that. All right, so let's send a message. The way you send a message is that you click enter. So this is the message the client created. And then it sent the message here to the front-end server. The client doesn't really know who it's sending it to. All it knows is that it's sending it to a port and a URL. Okay, this is the message that the front-end server received. Now, we're not logging in the front-end server the message that it's inserting. However, it does print out the fact that it is running in insert mode. And then it sent the inserted message to the backend server, which does log the message, as you can see here. So the backend server received this message first, which is the message that the front-end server inserted. After that, it then received the original message that was sent by the client that was forwarded by the front-end server here. The backend server received this message after it received the message that was inserted by the front-end server. And because it's running without Keychain, in both instances, the backend server believes that it is a valid message, and it went ahead and accepted both messages. Okay, so that is running the man-in-the-middle demo in insert mode without Keychain. Okay, so now we're going to demonstrate running the Keychain Man in the Middle demo with Keychain enabled and running in insert mode. So we start the client with Keychain running, and those extra messages that you see being displayed are proof that we are running with Keychain enabled. So let's start the front-end server with Keychain enabled. And it's the same command as with Keychain disabled with two different things. First of all, this needs to be running on port 9000, and we have one additional parameter, Y, which means yes, we want to run with Keychain. And this is a proof that we're running with Keychain, the fact that we are doing our license check here. And we'll do the same with the backend server. Start that up with Keychain. Again, this needs to be on port 9001, and with the additional parameter of Y, saying yes, we want to run with Keychain. And there you have it again. We're doing our Keychain license check here. In order to put the front-end server into insert mode with Keychain running, it's basically the same thing that we did when it was running without Keychain. You go to the Django administration screen. This has to be connecting to port 9000 because the backend server is listening on 9000 now. And we go to relay modes. If it's not already in insert mode, then you need to go to add relay mode here, and then select insert mode from the dropdown and click save. Now let's see what happens when we send a message from the client by hitting enter. This is the signed and encrypted message that the client has sent, which is, this is a message it created, and then it signed and encrypted the message, and this is it here, the beginning of it. And this is what it sent to the front-end server. So the front-end server has received the message and has decrypted the message. The reason it decrypted the message is because the front-end server is also paired with the client. And because of that, it was able to successfully decrypt the message. However, before it sends this message on to the backend server, it inserts its own message. And again, unfortunately, we're not logging that in this demo, but we do log it in the backend server. And if we take a look at what we received here, here is one of the encrypted messages. And so here's the first signed and encrypted message that the backend server received. And it decrypted the message. And this is what it received as its first message. This is the message that was inserted by the front-end server. And as you can see here, although it was able to decrypt the message, because it is also paired with the front-end server, it was not expecting this message to be signed by him. It was expecting the message to have been signed by the client. And because of that, it was able to verify the message, but it recognized that the message was from an unexpected signer. And as a result of that, it rejected the message that came from the unexpected signer. Now, this is the second signed and encrypted message it received, which was obviously the original message that was sent by the client. And so it decrypted the message, and this is what it is. And because it was expecting it to be signed by the client and not by someone else, you can see here that it was able to verify the message, and it accepted the message because it was signed by a known signer. That is our demonstration of running with Keychain enabled, running in insert mode. So what have we learned? When Keychain is being used, it successfully protects your data end-to-end before the transport layer. From device to device, Keychain provides the necessary protection to make sure that data is transferred and received and verified successfully.